Programming example for clockType. In C++, the assignment and member selection operators are the only built-in operators for classes. There are some other standard operators in C++. C++ allows the programmer to extend the definitions of most of the operators so that operators, such as relational operators, arithmetic operators, the insertion operator for data output, and the extraction operator for data input can be applied to classes. In C++ terminology, this is called operator overloading. The first statement declares myClock to be an object of type clockType and initializes the member variables hour, minute, and second of myClock to 8, 23, and 34 respectively. The second statement declares yourClock to be an object of type clockType and initializes the member variables hour, minute, and second of yourClock to 4, 5, and 30 respectively. Now consider the following statements. The first statement prints the value of myClock in the form hour, minute, second. The second statement increments the value of myClock by 1 second. The third statement checks whether the value of myClock is the same as the value of yourClock. These statements do their job. However, if we can use the insertion operator to output the value of myClock, the increment operator to increment the value of myClock by 1 second, and relational operators for comparison, we can enhance the flexibility of the class clockType considerably. Let's have a look at the modified definition of the class clockType, which implements the time of day in a program. It overloads various operators like the stream insertion and extraction operators for easy input and output, relational operators for comparisons, and the pre-increment operator to increment the time by 1 second. To overload an operator for a class, you must include the statement to declare the operator function prototype to overload the operator in the definition of the class. The clockType program uses the class clockType to implement the time of day. It also overloads the stream insertion and extraction operators for easy input and output, relational operators for comparisons, and the pre-increment operator to increment the time by 1 second. The class clockType requires the user to input the time in the form hour, minute, second. To begin, you must write the definition of class clockType. You must include the header files. Then include the function prototypes to overload the stream insertion and stream extraction operators. Next, define public and private member functions of the class. The function setTime sets the values of the member variables. The function getTime returns the time via the parameters. Next, include the function prototype to overload the pre-increment operator as a member function. Then, include the function prototypes to overload the relational operators. Overload the equality operator. Overload the not equal operator. Overload the less than or equal to operator. Overload the less than operator. Overload the greater than or equal to operator. Overload the greater than operator. Finally, include the constructor to initialize the object with the values specified by the user. If the values are not specified, the default values are assumed. Then declare the private member variables hr, min, and sec to store hours, minutes, and seconds respectively. The UML class diagram of the class clockType looks like this. Let us now write the definitions of the function to implement the operations of the class clockType. The definition of the function to overload the pre-increment operator is as follows. First, you must increment the seconds by 1. If seconds are greater than 59, set the seconds to 0, and increment minutes by 1. If minutes are greater than 59, set the minutes to 0, and increment the hours by 1. If hours are greater than 23, set the hours to 0. And finally, the pointer this returns the incremented value of the object. Next comes the definition of the function operator equal to. The two times are the same if they have the same hours, minutes, and seconds. Next, we write the function definition of the operator less than or equal to. The first time is less than or equal to the second time if the hours of the first time are less than the hours of the second time, or the hours of the first time and the second time are the same, but the minutes of the first time are less than the minutes of the second time, or the hours and minutes of the first time and the second time are the same, but the seconds of the first time are less than or equal to the seconds of the second time. The definition of the function to overload the relational operator not equal is as follows. In a similar manner, you can write the definitions of the other relational operator functions. Next, you must write the definitions of the functions setTime and getTime. The function setTime sets the three member variables, hr, min, and sec, to a given value. The given values are passed as parameters to the function setTime. The definition of the function setTime checks for the valid values of hours, minutes, and seconds. If any of these values is out of range, the corresponding member variable is initialized to 0. The function getTime returns the values of the member variables hr, min, and sec via the parameters. You can write the definition of the constructor by calling the function setTime. We now write the definition of the function to overload the stream insertion operator to output the time in the form hours, minutes, seconds. In this function definition, both parameters are reference parameters. The first parameter, OSObject, is a reference to an OStream object. The second parameter is a constant reference to the class clockType. The function returnType is a reference to an OStream object. Next, you must write the definition of the function to overload the stream extraction operator. In this function definition, both parameters are reference parameters. The first parameter is a reference to iStreamObject. The second parameter is a reference to the class clockType. The data read will be stored in the object timeIn. You need a local variable of type char to read the colon. This statement gets the input and stores it in the member variable hr. It also checks if the user input is valid. This statement gets the next input, which is a colon, and discards it. Similarly, these statements input time in minutes and seconds and check the validity of the inputs. Finally, this statement returns the iStream object is. Now you must write the program that shows how to use the class clockType. First, include the header file iostream and newclock.h. Next, you must write the statements to declare and initialize the objects myClock and yourClock. The hours, minutes, and seconds of myClock are initialized to 5, 6, and 23, respectively. The object yourClock is initialized to the default values. Next, you must write the statements to output the value of myClock and yourClock using cout and the insertion operator. Then, you must prompt the user to enter the time in the form hour, minute, second, and input the data into myClock using cin and the extraction operator. Following this, you must write the statement to output the new time of myClock using cout and the insertion operator. Next, increment the time of myClock. Output the incremented time of myClock. Use the function setTime to set the time of your clock to a new time. After setting the time, output the time of your clock. The next statement uses the relational operator equal to determine whether the time of my clock and your clock are the same. Similarly, the following statements use the operator less than or equal to determine if the time of my clock is less than or equal to the time of your clock and output the appropriate result. The body of the main function ends here. The sample run of the program looks like this. The output shows that the stream insertion, stream extraction, relational, and the pre-increment operator were overloaded successfully.